Number 8. So, an integration using a trig substitution, a definite integration. Well, as soon as you see some of that, you know square root of something minus something squared. It's going to be a sine substitution, because 1 minus sine squared makes cos squared. Square root goes back to cos. But anyway, we said that. Let x equal 4 sine theta, 4 to match the 16, which means that dx by d theta will be 4 cos theta. So dx will be 4 cos theta d theta. Change the limits at the same time. So if x is 0, 4 sine theta is 0, well that just means theta is 0. But if x is 2, 4 sine theta will be 2, so sine theta will be a half. That's 30 degrees, that's pi upon 6. Then start feeding it all back in here. So from 0 to 2 of the square root of 16 minus, well, x is 4 sine theta, so x squared will be 4 squared, 16 sine squared theta, times dx was changed into, I'm going to run out of space here, 4 cos theta times d theta. Now, I need a lot of room here. I think I'll do this changing over here. If you've got 16 minus 16 sine squared theta, you could take out the factor 16 and be left with 1 minus sine squared theta. And since cos squared and sine squared makes 1, that means that's the same as 16 cos squared theta. So I've got the square root of that. So that means I've got the square root of this, which would then just be 4 cos theta. So still be multiplied by 4 cos theta, d theta. Now we're getting somewhere. 4 4s are 16. Cos squared theta, d theta. Looking simpler, but I can't integrate that. I've got a function of a function which isn't linear. But you can change that using the double angle one. Cos 2 theta is 2 cos squared theta minus 1. Or rearranging that, 2 cos squared theta would be 1 plus it. 1 plus cos 2 theta. So that was 2 of them. I've got 16 of them, so I can do that 8 times. So I've got 8 of 1 plus cos 2 theta d theta. Now you can integrate. So I've got 8 times what that produces. Back up to theta. Cos goes back to sine. But it's got an inner function which is 2 theta. Divide by that derivative. So it will be a half of that. From 0 to pi upon 6. I didn't change any of these pi's upon 6's. That was a bit daft. You're probably all shouting away there. What about those pi's upon 6, mister? As they do. Then evaluate that. So what have I got? I've got 8 times, well, first of all at pi upon 6. So that's pi upon 6 plus a half sine double pi upon 6 is pi upon 3. I'm still okay with that one. Minus, and then 0 and sine 0, they're both 0. So minus 0. So I've got 8 times pi upon 6 plus, no, pi upon 3 is root 3 upon 2. If you don't remember that, you just have to remember your triangles. I'll put it into pound, shillings and pence for the sake of this. 60-degree triangle, 1, 2, root 3. Sine of 60, root 3 upon 2. So it's a half times root 3 upon 2. And then finally, just multiply out. 8 pi upon 6, cancel it down, 4 pi upon 3. That's a quarter, multiplied by 8 is 2, plus 2 root 3. So the final answer is 4 pi upon 3 plus 2 root 3.